cycle, right?
How do you spell that?
ACETO, capital C, small o, capital A. Acetyl CoA. Okay?
Okay.
And that goes into Krebs cycle, right?
Okay.
So at the end of Krebs cycle, what is your major production?
Well, if your
It's
transition it has acetyl CoA.
At the end of Krebs cycle, you're going to get your 6 NADH and your 2 FADH2s, right?
Right.
So, what we know is for every NADH, you get 3 ATP. For every FADH2, you get 2 ATP, right? For every NADH, you get 3 ATPs. For every FADH2, you get 2 ATPs produced. This occurs in the ETS. Okay? This occurs in the ETS. All right? Now, you see here with this chart, I got a total of 10 NADH produced, right? Through these pathways. I got a total of 2 FADH2s produced through these 3 pathways, right? Now, for NADHs, that will be 10 times 3 equals 30, right? FADH2s, I got 2 times 2, which equals 4, which gives you 34. That's why you have 34 ATP that are produced in ETS, right? Everybody see that? 34 ATP are produced because of the NADHs and the FADHs that are produced. Now you need to explain why, right? So, for the essay, you would say glycolysis is a metabolic process that occurs in 3 steps. What are the 3 steps?
Oh, it would be your transition reaction, your Krebs, and your ETS.
Glycolysis occurs in 3 steps. Investment. You have the investment of 2 ATP, right? At the beginning. That gets everything kick-started. So you have the investment stage. Investment of 2 ATP.
Okay.
Next step is the lysis stage.
The lysis.
Lysis. That's where that 6-carbon sugar, glucose is a 6-carbon sugar, right? That 6-carbon sugar must be broken in half. That is your lysis stage. Now I have 2.
For the 6 what?
Hmm?
For the 6 what?
Glucose is a 6-carbon sugar. It has to be broken into 2. That's the lysis. So now, what happens when I break a 6-carbon sugar into 2? I have 2 3-carbon sugars. All right? Now, I go through the energy conservation because there's still a lot of energy contained in these 2 molecules. So I can get 2 NADHs and I can get 4 ATP from those 2 molecules. Okay? That's the energy conservation. So, after the lysis, I'm going to be able to conserve that energy in the form of the NADHs, the 2 of them, which we're gonna use later on, and the ATPs. Now, you're saying, well, you get 4 ATP, right? Why isn't the net 4 ATP, right? That's a logical question. Why? Why do I not get 4 ATP out of this?
Because 2 ATP have to go back.
2 of them have to go back
Utilize.
and start the process again. Those 2 get reinvested, okay? That's why you only get 2 net. You know how you get your paycheck, you got the gross amount, and then the government takes out their tax, and now you have your net amount. That's the reason why. Glycolysis is like a government organization. It's gonna take its share and use it.
So glucose, the 6 carbon
Separate.
sugar, has to be broken into.
Do we have
Yeah.
to write all, we have to write all of, explain all of that?
Yeah,
Like
that's
the
why.
stage breaks sugar in half.
Yeah,
it'll
that's
be
why
2
I had you do
ATP.
this first, because that helps you explain it, that glycolysis, I'm getting 2 ATP, 2 NADHs, right? And I get my end product of pyruvic acid. So when I go through those 3 stages, investment stage, I'm going to have 2 invested, right? I'm going to have breaking of the 6 carbon sugar into 2 3 carbon sugars, that's your lysis. My energy conservation is I'm getting 2 NADHs out of here and a net of 2 ATP. My end product is pyruvic acid. Pyruvic acid enters into the transition reaction where I'm going to get production of 2 NADHs and acetyl-CoA. Acetyl-CoA goes into Krebs cycle. In Krebs cycle, I want you to mention in Krebs cycle that you have a series of substrate level. I'll let you write it down. A
Where?
series,
A series.
this is Krebs cycle, a series of substrate level phosphorylation. Therefore, you do not have to explain every single chemical reaction that's occurring in Krebs cycle.
Well, can you repeat what you said about the pyruvic acid? And
Pyruvic acid is the end product of glycolysis.
And it
You
yields.
you get 2 molecules of pyruvic acid from glycolysis. The pyruvic acid molecules from glycolysis are used in the transition reaction to convert to acetyl-CoA. During the transition reaction, you also get 2 molecules of NADHs. All right,
you also get 2 molecules.
NADHs. In Krebs cycle, the acetyl-CoA goes through a series of substrate level phosphorylations. So from Krebs cycle, you get 2 ATP produced, 6 NADHs, and 2 FADHs. Okay? Now, the FADHs and the NADHs, when they enter into the ETS, right, they are going to now go under what we call oxidative phosphorylation. Now, when something is oxidized, what happens when something is oxidized?
Is it they lose them?
When something is oxidized, they lose their electrons. So all those H's that are on the NADHs and the FADH2s, those are electrons. So when they go into the ETS, they lose those electrons. Those electrons will then produce what we call a hydrogen gradient on the outside of the cell. Now, what do we know about gradients? It goes from high concentration to a low concentration. When it does this, those hydrogens pass through what we call a ATPase. Anything that have ASE at the end is an enzyme, right? This ATPase makes what? It's an enzyme. This enzyme is called ATPase. So what does it make?
Adenosine?
Triphosphate. It makes ATP, right? That's where you get 34 ATP produced in the ETS, because your NADHs and your FADHs carry those electrons. Those electrons are going to be made into ATP because the electrons go into the cell membrane.
I got lost after hydrogen gradients.
Hydrogen gradients? Yeah, it creates a hydrogen gradient on the outside.
Okay, and then?
And then those hydrogens will come back through. They pass through the ATPase, which is an enzyme that converts that energy into ATP. And because I get 3 ATP from every NADH, and I get 2 ATP from every FADH2, how many do I get from the whole process up here? I got 10 FADHs and 10 NADHs and 2 FADHs, right? When I do the math here, 10 times 3 is 30. 2 times 2 is 4. You add those together, you get 34 ATP that are produced in the ETS because of that energy conservation. All right?
Let me read what I have and see if this jives, because you're going so quick. Glycolysis, you are.
I'm actually going pretty slow.
Glycolysis is a metabolic process.
Yes.
3 steps. Your investment of 2 ATP, and then your lysis stage breaks your sugar molecules in half, and it yields 2 ATP and 2 NADH. Your end product is pyruvic acid, which yields, then converts to acetyl-CoA. And then your transition reaction yields 2 NADH. Your Krebs cycle is a series of substrate level of phosphorylation and yielding 2 ATP, 6 NADH, and 2 FADH. These are oxidized and lose electrons in the ETS, where your hydrogens travel through gradient producing ATP, which yields the combination of 34 ATP at the end.
And so those 34 ATP at the end, adding with the 4 ATP that were produced, 2 in glycolysis and 2 in Krebs, give you a grand total of what?
38.
38 ATP.
But that's not in the ETS, that's just
No,
your
that's
overall
overall.
process. And so after it yields 34 ATP in the ETS, then you say it yields an overall process
The whole
38.
metabolic process produces a net of 38 ATP. And believe me, this is the very simplified version of it.
Because I was trying, I'm not so sure about that. Don't you take like a mini break?
A mini break? What time is it?
Like 11,
Okay.
if you can read
You guys want to take a mini break to clear your head?
Can I take a picture? at a time.
Okay, let's take a mini break to clear our head.